Okay, so this is perhaps the last tutorial for this class. In this tutorial, I will show you how to create a raster layer based on point data. The reason why we want to do it, because in many cases in the real world, when we want to make measurements about properties on the ground, like temperature, precipitation, in many cases, we can only do point measurements, right? So for weather data, climate data, the data can be only finished in many cases on the ground or close to the ground at different locations. And the issue is that how should we create a layer with data for every location within the extent of the map, right? So then we'll need to use the method of interpolation. Okay, so make sure you have your new project file, lab5_S4, and then you will need to add, the precipitation point layer, and yeah, you see I have many, so I have different folders. Precipitation point layer, add it there, right? Add it there. All right, so there are points. Each point indicates one weather station within the province. Next, let's look at the attribute table. Right? A station ID, each one has a very unique ID. And then the name and coordinates, longitude, east, latitude, easterns, northerns. And then the records, historical records from different years. 1916A is the record for this station. B indicate the record from the closest station. So we will be making the map based on a column of year plus A, right? So the most recent year in this data set, 2005. Right, so we'll be making a map based on this column, 2005A, explore statistics. We haven't talked about normal distribution, right? So yeah, that's close to normal distribution, right? Close to normal distribution. Minimum, maximum, minimum 553, and maximum 1254 millimeters every year. Not every year, for year 2005. Right? So there should be some special pattern there, within the province. And we should be able to map it based on the interpolation method. Now let's close the attribute table. And interpolation. So there are different methods of interpolation. We'll use the most straightforward ones. So even though it's very straightforward, but it's still being commonly used to create a raster layer for precipitation and temperature and other parameters. We'll need to start from analysis. Tools, start geoprocessing pane, and then input IDW, right? Inverse distance weighting. Select the second. Oops. Okay. Right, it's the same thing. Input features, of course, precipitation, and Z value, that's the precipitation value, will be 2005, and A, output raster precipitation, right? Precipitation. And output cell size, so if you want to click on the information icon, the cell size is at which the output raster will be created. The value can be determined in the different pane environments, which is here. And if not set, it is short of the width or the height of the extent to the input point feature in the input special reference divided by 250. So for here, so the software create one for you, determine cell size for you, which means that for the basic cell, because raster whose smallest unit is pixel or cell, each cell in the raster is corresponding to 4,379 meters on the ground, right? So the cell size, so one block of 4.3 by 4.3 square kilometers, 16 kilometers correspond to one cell. We can change this value a little bit. Just say one cell is corresponding to 1 kilometer. One cell is 1 by 1 kilometers. Right, 1 by 1 kilometers. And the power which means that the significance of significant neighboring points on the estimation of value for one location, right? Right. So you can change the value. You can change the value again. You can click on high. Higher points results in less influence from distant points. All right. So we just use default one for this exercise. Right. And then we need to click on environments. Click on here. Output coordinate system. We can use that one from the point layer presentation. And mask. If we don't indicate a mask, the software will create values for a square or rectangular area. Instead, we would like to have an export shape of Ontario, right? So instead, we will want to use the Ontario layer from the folder, right? Ontario layer from the folder. And I think, yeah, that's it. And you can click on run. Yeah, it may take 10 seconds, 20 seconds, depends on speed of your computer to finish the processing, right, to finish processing. And after it's been processed, right, so the results being automatically added. Right, so one layer, right, so one layer. So the different ranges being classified, assigned as different colors, right, different colors. And so that's symbology, right, classification, symbology, classified, method, geometric interval, that's good. You can use natural breaks, no issues. Um, Geometric interval, both considering the clusters of the values, but and also try to balance the number of pixels within different ranges. What I tell you want to do. The color scheme, the number of classes change to 7. All right, change to 7. We don't want to have a very complex map. And the color scheme, the presentation or presentation, you need to check the show names and scroll down P presentation. So that's the default one. Yeah, that's the default one. And it's here for the label. Well, it's the version 3.2 is much more convenient than previous versions, right? From the 3 decimal places does not make sense for us to keep the 3 decimal places in the label in the legend. So instead, we can just we can change the settings through here, right? Advanced symbology options, or we can just change from here directly. Decrease the number of significant digits or decimal places. Click the once, twice, or 3 times. Right? 3 times. Yeah. So that's it. That's it. And that's it. That's it. And next, you need to make a map, right? Before you want to move forward, you don't want to show the precipitation layer, point layer. You just want this layer, right? And then click on Insert Layout. I will use the portrait. Use the portrait. Again, insert map frames. You may want to change the size of the template. Right? You might want to change the size template, right, to make it bigger, activate it, right? Center it, right? So what you need to do, you will want to change, right? So we will not want to have we will not want to have layout a letter size template. Instead, you want to shorten the height. So please follow the instructions from section 1 to do it. And you will need to insert so go back, right? Go back, insert the legend, right? So the legend, yeah, so maybe here. Legend. Again, you notice that the legend title is not necessary. Presentation, of course, you want to change it. Presentation, what is the unit? It is in millimeters, right? It is in millimeters. It is in millimeters, and you want to delete you want to delete the you want to delete the value here, right? You want to delete the value here. Right. You may also want to insert the scale bar. You determine where you want to place it, and you want to have a title, right? You want to have a title. And because the classification method is geometric interval, you may want to insert it somewhere, like say some here, right? Because there's a gap here. And then you can just move the components, map components around to make the map looks organized, balanced. Okay, so I believe this lab section is very straightforward. We just need a little bit of patience and to fine tune. Okay, so the output template size and to adjust the positions of the map components. Okay, that's for this tutorial. I hope that all the tutorials I created had helped you to finish the lab assignments.